Now, if you have ever been confused about how solar panels work or how sunlight is made to power an entire building, then this video is for you. Because with this simple diagram, I'm going to walk you through step by step how exactly this whole thing works. If you stay with me till the end of this video, you should never be confused about how sunlight is made to power a building anymore. My name is Michael from Valuemine Solutions. You're welcome to our solar education series. If you are just joining us for the first time, please do not forget to hit the like and subscribe button so that you see more videos like this in the future. With that said, let's jump right into the video. Right, so the first thing I want you to see here is this solar panel here. Now, if you've ever seen a building that is solar powered, one of the first things that captures your attention are the solar panels on the roof. Now, you see these solar panels here are the powerhouse because this is where power generation comes from. This is responsible for the generation of electricity. Now, so the question is, how exactly does this solar panel generate electricity? Now, you see, let me pull up my pen quickly so that I can be more explicit here. Now, this is the solar panel. It is also known as a solar module. This solar module is made up of tiny boxes known as cells. Okay, each of these boxes are cells. These cells are connected together in series, right, to increase the capacity, because a tiny cell is not enough to power a building. So all these cells are connected together to increase the voltage and current. All right. So each of these tiny cells actually make this giant module, right? Now, the question is, what material is actually used to produce or manufacture these solar cells? Solar cells are mostly made from silicon, a special semiconductor, right, known as silicon. This is what silicon looks like. So this here is what silicon looks like. Okay, this is the material used for manufacturing solar cells. All right. Now, silicon itself is actually gotten from sand, but not just from any sand, not from any type of sand. It's actually gotten from a cleaned and refined sand called silica. So this is silica. This is what silica looks like. So let's get back to the solar panel. Now, this solar panel, like I said, is the one responsible for power generation. Okay, and it works when light hits the surface of the solar cells, right? So when light from the sun, when the solar module or solar panel is exposed to sunlight, to any type of light actually, the photons or light particles from the sun hit the surface of the solar cells. Okay, the photons, right, or light particles, because the particles that come from the sun, these light particles are actually called photons. When these photons hit the surface of the solar cells that make up this module, right, they set in motion certain particles known as electrons. Whenever electrons are in motion, right, electric current is generated. Electric current begins to flow. The flow of electrons is the same as the flow of current. So when these light particles, these photons, hit the surface of the solar cells here, they set in motion electrons. Electrons inside each of these solar cells begin to what? Begin to move, right? And this causes flow of current. And there you have it. That is how electricity is generated or produced. This solar panel, when the current is generated, when current begins to flow in this solar panel, then you have electricity. But the problem is, this only happens whenever there is sunlight. As soon as the sun sets, okay, as soon as the sun sets, this solar panel stops producing electricity. Once the sun is up again, it starts producing electricity. Once the sun is down, it stops producing electricity. So we have a problem here. How exactly do we get this electricity to work at night? Because if we only get electricity during the day, then that's almost useless, because even most people go to work during the day. So how do we capture this electricity and save it up for night time. Well, that is why we need a battery, and that's the work of a battery. So here is an example of a battery. This is one of the battery types used in an inverter or solar system. This here is called a flooded lead acid battery or tubular battery, right? This is a tubular battery. Now, the function of any type of battery at all is to store electrical energy in form of chemical energy. So here's how it works. The current flowing from this solar panel, right, is passed through a cable, also known as a DC cable. It's passed through this cable and then down into this battery to charge the battery. So the electric current flowing from the solar panel is made to charge this battery. Now, when electric current flows into a battery, it sets off a chemical reaction, okay, that begins to charge the battery. So the electrical energy is converted to chemical energy, and this chemical energy can be later used again to supply electricity. All right, so that is exactly how it works. But then we have another challenge here, and the challenge is, if this solar panel is made to charge the battery continuously by itself, because the currents and voltage keep varying, right, at some point this battery can get damaged. Aside from that, the solar panel can actually overcharge the battery. Okay, so how exactly do we prevent the battery from getting overcharged? Because overcharging a battery can damage the battery. So how exactly do we control this charge and discharge cycle of the battery? And this is the answer. We make use of what is called a charge controller. So this is a charge controller. This device here is known as a charge controller. This is a charge controller. So this charge controller is often put between the solar panel and the battery so that it can control the charging process. Okay, so this charge controller is very, very important in a solar system. Now, there are various types of charge controller. There are two main types of charge controller. There is the PWM charge controller and there is the MPPT charge controller. But we'll do another video to explain that. Okay, so let me go over that again. When photons or light particles from the sun hit the solar cells that make up this solar panel and generate electricity, the electricity is captured through this cable, flows through this cable, right? The current flows through this cable down through a charge controller which controls the charging of what? Of the battery. All right. So now the question is, so how then do we get this electricity from the battery? The battery has stored up the electrical energy in form of chemical energy. How then do we get this energy back? Another question is, can I just connect my TV or my fan or my, or my microwave or my light bulbs directly to this battery? Well, the answer to that is no. You cannot connect your TV directly to the battery. And the reason is because the currents produced by solar panels and batteries are known as direct currents. Most of our appliances at home, like our TV and fans and freezer, bulbs and the likes, they work with alternating currents. So let me show you. So there is something called DC current, right? This is DC current, okay, and there's something called alternating current, right? Most of our appliances at home, like our TV, fan, microwave, freezer, and the likes, all work with alternating current. Okay, they are powered by alternating current. They cannot be powered by DC. Okay, they can only be powered by AC. Oh, so it means we cannot connect our TV and fans and microwave directly to our battery. Exactly. So how then do we convert the DC current from our battery to AC? Well, we need an inverter, and that is the job of an inverter. So the role of an inverter here is to convert the DC current coming from the battery to alternating current usable by our appliances. All right. So, and this is what the inverter looks like. This is an inverter. All right. What you have here is an inverter. So the role of this inverter is to convert the DC current coming from a battery to AC current. Now the capacity of this inverter will determine how many appliances it can power. So inverters come in various capacities, right? Also, the capacity of your battery determines how long it will keep supplying electricity. Remember, you have stored up electrical energy in form of chemical energy in this battery. The more your battery, the more electrical energy you can store up in form of chemical energy. So, in the solar world, batteries are actually precious. Why? Because they help us store up energy for times when there is no sun. So, on days where there is no sun, during the night and on cloudy days, your batteries will come to your rescue. That's why it is good to have as many batteries as you can afford. All right. So the work of an inverter here is to convert the DC current from the battery coming from the battery so that it can power our appliances at home. Now you can see it's a very simple system, right? I tried my best to make it as simplistic as possible. I hope you learned something from this explanation. So if you found this video useful, then watch out for the next series of videos because we're going to do our best to give answers to all your questions about the solar systems. So if you have any question at all, please drop it in the comment section and we will address it. Also, if you want us to make a video about any aspect of solar energy or solar systems, feel free to drop a comment in the comment section. So if you found this video useful, please don't forget to hit the like and subscribe button to see more videos like this. I remain Michael, your host from Valuemine Solutions. See you on the next one.